Hi, my name is Denny Lee. I'm from Microsoft. Some of you might or might not know me. I'm with the analysis services team. Also happen to be on the team that had brought Hadoop into Microsoft. So there you go.
And I'm Diane Cantwell. I'm from Yahoo, and I work on our Tau Cube, which you'll hear about today.
Yeah. So today's session is Yahoo, Big Data, and Microsoft BI, bigger and better together. Okay. Before we start, I wanted to ask a quick question for the crowd here. How many folks are more IT focused versus business focused? Just curious. IT focused. Cool. Business focused? Okay, cool. All right, so for the business focus, we do have stuff for you too, so don't worry, okay? But it's more IT focused, okay? There is much more geeky stuff inside here, so we want to give you the heads up on that. There are also, I don't know if that scares you or you like it, there are actual references to Deep Space Nine and Battlestar Galactica in here as well, so as a heads up.
They're not my references.
Yeah, they're mine, of course. So in fact, if you can figure out what the reference is, then in fact you can win a book. But that's just me tossing some of that out there. So just as a quick call out to the IT folks, to the business folks, it might get really weird, wonky fast on you. IT folks, hopefully you'll enjoy it. All right. So I think that's it. Let's see. Oh.
Battery in over here.
There we go. Please sign cell phones. Okay, you guys know that stuff. So, okay, let's go right to the agenda. Actually, you know what? Let's make sure my cell phone sounds. All right, here we go. All right, so the agenda here for today is that we're going to first talk about the business case on why we actually have a BI system like analysis services going against Hadoop. Okay, there's actually very good business reasons behind doing such a thing. Okay, not just the coolness of doing it. By the way, from the IT perspective, the coolness of doing it is that in fact Yahoo has the largest analysis services cube on the planet. Okay, so for any of the folks who have worked with analysis services, usually when I say, hey, what's a really large cube, people answer back, oh yeah, a terabyte or 2 terabytes, and that's a really large cube to deal with. Well, at Yahoo, it's a 26 terabyte cube. It's the largest cube on the planet. Okay, so it has its own set of issues. We will try to share the good and the bad in the process of this session. But we definitely want to start with the business. But again, for the techs, there you go. And that's actually what the themes of this next section is. Some of the main themes that we talk about when it comes to the technical issues that are surrounding such large cubes against something like Hadoop is that we have to get the hardware right. Okay, this is actually really, really important. Be really good friends with your systems engineering folks. Okay, the folks that run the hardware. Start buying them beer. I'm serious. That is a very effective methodology of getting them to actually help you out. Okay, there is a theming of partitioning. If you've ever seen me and Thomas Kaiser in any of the past sessions, you'll notice that he and I have this almost obsession about I/O and partitioning. Okay, so that theme still comes into play. Keep it very simple, okay? Not like the way I'm talking right now. Keep it simpler, all right? Make it easier to deal with. And also there's a reference to it is the order of things. How you order things, how it's done, is actually really, really important. We're later on, after a Deep Space Nine reference, you'll see actually how, in fact, because we got the order wrong, we actually blew up the cube to almost 40 terabytes, okay? By accident. That's a really hard accident, okay? So just as a quick call out. All right, so these are some of the themes that we'll be talking today, okay? And now we're going to right to the business. Diane, take it away.
That's my side.
Yes.
So let's see. We're in Chicago, so I'm going to compare our ad network to the CBOE, the Chicago Board of Options Exchange. Normally, you just look at any kind of stock exchange, and in a stock exchange, you have buyers, you have sellers, and you have this network. And the network itself is highly, highly optimized so that you can't really game it easily. So we want to apply the same model to the Yahoo ad network within Yahoo. So what we're doing is we're taking the data that's specifically associated with the ad exchange. It's actually the performance part of the advertising network within Yahoo. And Yahoo has built a network or an exchange around it, and we're trying to help make it optimized or make it as efficient as possible. The outcome of that is that we'll drive a lot more conversions, we'll have more advertisers, more publishers, more people coming onto the network, et cetera. So ultimately, this data is there to drive that. So let's see. Targeting is how we do that. So every campaign that is run through this network is targeted to an audience. So we need to hit the right audience at the right time. You've heard that a million times, I'm sure. And then ultimately, we need to be able to report on that and give the feedback so that we can close that loop and update the targeting and make it more and more efficient.
Oh, and so just to chime in, yeah, just if you look at it from the context of this web page, right, this is the Yahoo homepage, right? And so in other words, that ad that you see there, we have to make sure that it actually is more applicable to you. In other words, if you're based in Chicago, but then we send you a bunch of information that's for Florida, not so effective unless you happen to be a Floridian, right? So if we happen to know you're a Floridian, great, then that might actually be effective. But otherwise than that, that ad has to be better designed from the standpoint of what geo you are, what your behavior is, what your what your gender is. And in fact, that's what the next section is going to be about.
So what we have lots and lots of different dimensions. In fact, we have 42 dimensions in our cube, and most of them correspond to attributes of the individual user or the advertiser or the site that the ad's being served on, but these are all information that is relevant to that banner ad that's being served on that site and how we go about optimizing it. So, but it's a problem, right? It gets pretty complex. It's easy if you're just looking at one of those dimensions. If you're looking at two, that's a little harder. If you're trying to combine 4 or 5 of them, well, that gets even harder. So, and really, we need to be able to do this on the fly, and so that people who are optimizing these campaigns can do it very fast. So it's the more dimensions you add, the more complex it gets, and that's part of our challenge. So let's see, technically speaking, we have about 680 million people that visit the Yahoo branded sites. In terms of ad impressions, an ad impression is a single banner advertisement served on one page to one set of eyeballs at one time. So we're inside of this performance network. We're serving about 3.5 billion ad impressions per day. And that data is making it into this Tau cube. By the way, we refer to Tau. His name came about 5 years ago, and it stands for Targeting, Analytics, and Optimization. I think it was just a code name at that point in time, but here we are 5 years later, and it's still there. The number of rows loaded, now this is rows loaded into Oracle, ends up being about 64 billion per quarter. This is actually more than the number of ad impressions. And the reason why is we have 2 main fact tables, 2 large fact tables. We have a few smaller ones, but one of them is associated with those actual ad impressions. It's rolled up a little bit. We group away a tiny bit of data, but it's only about a 2-to-1 ratio there. But the much longer and deeper fact table is for something called segment data. And I won't go into the details of it, but it ends up being a many-many relationship. Because if I'm serving an ad to Denny, and Denny belongs to 10 different user segments, maybe he's part of dads and geeks and Microsoft enthusiasts or Mac enthusiasts? Oh no. He's going to belong to 10 different segments. Well, that ends up as 10 different rows inside of our fact table specifically for segments. So as you can see, the data gets pretty big pretty quick.
So before you go on,
Yeah.
though, I like to ask a question. Where do you actually put all of that data?
Where do we put it? It ends up in multiple places, but ultimately it's in Oracle, but it's also that granular data is inside the cube itself. Yes?
Is it an Exadata device or is it a plain rack?
It's in a rack.
Oracle Rack, yes.
Yeah.
Sorry, the question was it an Exadata device or an Oracle Rack? The answer is an Oracle Rack. Now, the source of this information, though, okay, is quite large. In fact, we're going to flip that to the next slide.
So let's just finish out this one real quick. And so as far as the frequency of the data, we do allow users to report hourly. So we keep the hourly granularity of the data. And we refresh that cube. It's an ongoing loop. So basically, we build out new data to the cube. We see whatever new data is there, and we do another run. Now, ideally, we're updating that 4 times a day. It doesn't always end up that way, unfortunately. But we do have a 24-hour SLA for that cube.
How are you getting your data from your ad servers? Are you using the web logs or are you streaming site or similar?
So we're getting what we call a CDF, a custom data feed, raw logs delivered to us into the grid, and then pulling down through Hadoop. And Denny will go into more of that later.
Yeah, we'll go back in a second.
And then the other part of it is that for this data to be truly useful to our users, they can't just submit a report request and get it the next day. It doesn't work that way. It's on the fly, ad hoc, querying of data, anything by anything. It gets, again, pretty complex pretty fast. So the average query time needs to be under 10 seconds. There are certain types of reports that are going to take longer, but the interaction needs to be quick.
Can I ask you a question to follow up on that? You said anything by anything, right? So do you have a lot of rigid hierarchies defined, or are you basically supporting a slice and dice however they want.
So the question is, are we truly giving slice and dice by anything, or are we defining specific rigid hierarchies? So in the cube, we have everything by everything, but as we'll see later, we put a lot of effort into the aggregation design. So every quarter, we go through the web logs, or the query logs, I should say, of all the queries that are run. We look at average query times. We look at when the queries hit the partitions versus hitting the aggregations. And we can't do an aggregation for everything, but we hit the vast majority of them. So, and that's an ongoing process because what people are querying changes as well. So I don't know if that answers your question. But
Your question over there.
yeah.
Specifics around performance with your many domains.
So in terms of our segment, so are you talking about that segment fact table? And we have so many relationships in the physical cube. But in terms of that fact data, when users are querying against the segment data, it does take substantially longer to query that data. The data is also, it's simpler, so it's much narrower. So we remove a lot of those dimensions. A lot of the user dimensions are removed for the segment data itself. But query time, I don't have that breakdown right now of segment data versus the activity side, but on average, I would say the queries are probably about 10 seconds on the segment side, whereas 2 to 3 seconds on the activity side. Roughly, yes.
How do you update the cube hourly? Like, is that something you do in the partition update that you do, ample rep versus hourly or something like that?
Well, the granularity is hourly of the data. When we build or we add data to the cube, that happens, like I said, 4 times a day at best, 1 time a day when it's not quite as good. At that time, we reprocess all the dimension data. So, and we do a process add on the dimension data, and then we add the new partitions and the new fact data. We never do a process update, which Denny will get into later, because that's disastrous on a cube of this size. But yeah, and so with each run, we're adding some amount of data, usually somewhere between about 6 and 24 hours of data gets added to the cube with each run. Okay. So let's see. Denny will go into some of the details later, but this data is getting loaded into the grid. We are then ETLing that data there. So rather than doing it in Oracle, we do a small amount of aggregation. We remove the cookie ID, and we only have a hashed version of it. But the uniqueness of the user does get aggregated out, but all the other dimensions remain in the data. So on what I'll call the activity side, which is where we're hitting the actual 1 row per ad impression, the data goes from, say, every 2 rows go down to 1. So it gets to about 50% of the size. On the segment side, it rolls up a little bit more, but it's compressed to about 1/3 of its original size. So, but that happens on the grid. It doesn't happen further downstream. The data is then loaded into Oracle, kind of a long-term Oracle shop. And it's, at that point in time, our ETL is very simple. It's basically passing the data through. We're not doing anything there. We make sure any actual ETL transformation happens upstream. So we use external tables to load the data into Oracle. And then our partitioning scheme is that we partition the data by hour and then also by market. A market for us is associated with kind of a regional area of the US, or not the US, of the world. And it's how users end up querying the data in the end. So the idea is that we care a lot about partitioning. We partition in Oracle the way we want to partition in the cube, and ultimately that's driven by how the users are going to query that cube, which is they're looking at timeframes and they're looking for their regional area, because they're generally querying that way.
So is your data in Oracle already in the right schema so that you don't have to deal with any data views in the cube?
So in terms of the fact data, we only have 8 fact tables, the dimensional data. So the dimensional data, we do use views. We have one schema where the underlying data is pulled. It's actually pulled via an API from a different system, populates those tables. We have some other tables that are updated via a web application where users can actually make changes to the data, categories, things like that. And then we have views on top of those that for each dimension, basically. I mean, it's a little more complicated, and then those views are what are read by the cube.
So just to let me chime in a little bit on the technical side of things. So basically, with the previous screen, I was trying to pose the question, like, how do you store all this data, right? The first 3 here, like in terms of the numbers, right? 3.5 billion ad impressions, 464 billion rows per quarter, things like that. How do you store all that? Well, in fact, how Yahoo does it, which makes complete sense since they're the creator of Hadoop, is to store it in Hadoop. Okay, duh. Right. So they have, in this case, a two petabytes of data in a 14 petabyte cluster that actually is holding all of this data. Okay, due to exactly what Diane was talking about in terms of aggregations, trying to shrink the activities down so we can shrink the number of rows. It's still, our version of shrinking is still 1.2 terabytes of data a day. Okay, so that's still a lot of data that has to come through. We managed to figure out how to compress it because when the cube goes ahead and grabs the data from Oracle, all right. Basically, this is probably more my opinion than Yahoo's opinion, just as a quick call out. But it's more like this is one of the most expensive staging databases I've ever seen in my life. Because in essence, that's its purpose. It's just to hold it long enough for us to shove it into the queue. That's what we're really doing.
Yeah.
In fact, later on, we're going to talk about some other options we've been looking at to try to make it a little bit cheaper. Okay, but nevertheless. The idea is that we actually have to move basically at least 135 gigabytes of compressed data a day from Oracle into AS. Okay, so it's a lot of data that just keeps being built up. And the reason we're doing this as an overall theme, going back to this particular slide, is that the Hadoop part allows us to tackle the first three. Okay, the BI part, the AS part, allows us to tackle the bottom two. Okay, that's basically what it comes down to. That we have two distinct set of problems. One is the huge amount of size, the fact that the data is unstructured because it's weblog data. Okay, schemas can change all the time on us if they want to. It is weblogs after all. Okay, so we have to be able to go ahead and store it anyways because that's a lot of very, very valuable data that we have to figure out. Okay, but then there are also just like the requirements. We have to query this data. And last time I checked, I can't query Hadoop and get it back in a matter of seconds. Don't get me wrong, the folks at Hortonworks are trying to work to figure out exactly how to do that, but the reality is that we're still not there yet, okay? And so until that point in time, what can we do? Well, here's one of the ways we do it, in fact, okay? And yes, question there.
Are the logs stored compressed on GitHub?
I'm sorry?
Are the web logs stored compressed in Hadoop or also?
Oh, at least to my...
In Hadoop?
Yeah, Hadoop.
I know they're compressed in Oracle. I'm not sure if they're compressed in Hadoop.
Okay, to my understanding, they were compressed in Hadoop as well?
Yeah, I
In order
believe
to save
so, too.
space, but I don't
Yeah.
quite... really, man, I'm a little...
Pretty
rusty
sure
on
they
that.
are.
Yeah.
I'm not on the Hadoop side, unfortunately.
Yeah, mainly because we haven't looked at that thing in a while, admittedly enough.
My estimation is the Hadoop is about 2 petabytes, the Cube is about 24 terabytes. How big is the staging environment?
I did not get stats on that.
Yeah, we don't. Okay, so the question was the Hadoop is 2 petabytes of data in a 14 petabyte cluster. The Cube is 24 terabytes. How big is the Oracle? We actually don't remember. Sorry.
Somewhere in between the two.
Yes.
I know that much.
One last question on your implementation.
Sure.
Your files are coming in from your different web servers, so I'm assuming you have to aggregate across files.
Okay, so the question is, data is going into Hadoop from multiple file servers, and the question is you aggregate across files. When you're saying aggregate across files, what's the context here?
Well, because you're aggregating down to, I'm assuming, well, no, you're not aggregating at the user level anymore, so your aggregations are happening at the campaign level.
Activity level. Yeah, at the event level. So the question was basically, can you...
Events will be coming in from different web servers.
Yes. In other words, okay. So the context, I think, the question is that since the data is coming from multiple servers, like are we basically aggregating across all of these different files from all these different servers? The answer is yes. It has to because we've got a lot of events. There's segments that everything's aggregated up to that makes it very interesting, but the reality is that the most basic component is the activities table or events. In other words, when you go to a website, you click on something, you look at something, you look at an ad, that's an event, okay? So that's the most basic concept, and so yes, we have to aggregate across the events, otherwise we don't know what a user is doing. Simple as that, yes.
I'm really curious why you have Oracle for the staging side and Microsoft for the BI side, not the same solution either way.
Actually, no. It's a great question, and I'm not trying to avoid it, because in fact I've got a slides on that later on. Okay, so the question is, we have got Oracle here, right, and we have AS here. Why don't we just either stay with Oracle, which would be weird for a Microsoft guy to do it, or stay with SQL Server on both sides? We actually have a little bit better answer for you later on the slides. Okay, so part of it's just the way the business works. Part of it's also there are like valid technical reasons too. So we'll.
In terms of original history,
Yeah.
this started at a startup where I was with another person. He's really the main architect behind all this. He's no longer with Yahoo, unfortunately. But he's an Oracle guy, and we got into Yahoo. Yahoo was an Oracle shop. So originally, I would say that was the biggest driver. But ultimately, we do have other challenges, and we need to revisit that, which is what Denny will get into later. Yeah.
Cool.
So,
yeah.
okay.
Let's go on. Yeah. We're already
Yeah. Okay.
Yeah. Go for it.
So let's see. As I mentioned before, there are about 42 dimensions. We have 296 attributes, 278 measures. For us, that's pretty complex. There's a lot of data there. And ultimately, as we mentioned earlier, users want to interact with this at the, quote, speed of thought. So we have two different interfaces into that cube. Again, 24 terabytes of data in the cube. We have kind of higher end users that are using a visualization tool called Tableau. And they're the ones that are interacting on the fly with the data. And I'll show a demo a little bit later if we have time. But really, they want to be able to look at pretty much anything by anything on the fly, again, interacting with the data. They're not pulling reports. The second set of users, and these overlap quite a bit, they're using a web application tool that it does pull specific static reports. So it pulls the data directly from the cube via MDX, displays that data, but it allows users to take action on it. So for instance, if they pull a report and it shows them that certain demographics are performing really well, they can literally click on those, hit target, and either create a new campaign or update the existing one to target those segments. It automatically goes to the system where that stuff is managed, makes that update on the fly. So that's kind of how these get used in conjunction. Generally, the people are using the Tableau interface right now to interact with that data, find all kinds of insights, and then using that web application tool to be able to apply those.
You get timing, actually.
What was that?
Timings.
Okay. Got it. I didn't actually go through the slides that way. So on the Tableau side, right now, our average query time is about 2 seconds. For certain types of queries, it takes much longer if they're looking at a quarter of data across an entire region, that type of thing. On the web application side, since they're kind of pulling everything in once as opposed to individual attributes, the query time is about 5 seconds. We would like to get these better. We're working on it, but that's where we are today. Lots of questions over here.
Yeah.
How many concurrent users do you have at any given time? What's your sort of user base?
Total, we have about 300 because it is a pretty specialized application. Concurrently, like 20-ish, but I don't have exact stats on that right now as far as the concurrency. Yes? How many what?
Distinct count measures.
Oh, good question. We're actually, we'll get into that a little bit later. We're not doing the distinct counts right now.
Yeah.
Yeah.
We've tried.
We've tried. It's a big challenge. It's a very big challenge.
So
yeah.
if you want to go just to take
you want me
a
to-
little off tangent,
Okay.
just a little. Sorry, off tangent. Yeah, we can talk about distinct count probably in a different form than this one because it's going to get really long, really fast. There is a paper out there, analysis service distinct count optimization. I would follow that paper, okay, in how to do it. But ultimately, what it comes down to is this is why Thomas Kaiser and myself are very obsessed about I/O. In fact, he was so obsessed that he became the CTO of Fusion I/O, okay, over in EMEA. So that tells you how obsessed he became. In order to improve distinct count performance, you basically need the fastest I/O. That's what it boils down to. So there are things that you can do to try to optimize for that. That's the simplest answer I can give you without just taking the whole session. Okay?
Yes.
What's the data lag? How long is the lag between when occurrence happens on the website and you get the
Yep. So our SLA is 24 hours. That said, we're not always within SLA. I'll be honest. When there's problems upstream, then it falls below that. Best case is about 8 to 12 hours. But we really want to get that down, and we're working on some other models, a smaller cube that would be built much faster, some other things, because it's important. These campaigns on average last about 2 weeks. So the longer you wait to get them the data, the less time they have to actually react and respond to that data to change the targeting and have impact on that campaign before it finishes. Yes?
I think you said that you have new partitions on every load, right? So does that mean you load the old data into old partitions and then you don't touch those?
For the most part, yes.
Just
Yeah.
to repeat the question, Old partitions are left alone. New partitions are basically added, so we don't really touch the older partitions. Yes, as a general rule, because it's web analytics, there's very, very rare occurrences where you actually have reconciliation of web logs, right?
Pixel conversions, is that in there too, or is that in a different?
So okay.
Yeah, they are. They're in there, and when they arrive, they're in. But yeah, some of that stuff, it does get added in later into other partitions.
But you can add them to other partitions.
it's-
You don't have to go back and reconcile the previous partitions to do such a thing.
Yeah.
Yeah. So.
What's the server used now for, so the capacitors, how many processors, how many?
What's the capacity servers?
I meant
That's
to,
an IBM.
meant to have it on the, yeah. But they're 48.
Yeah, it's a 48 core.
gig.
Yeah, okay.
Yeah.
So it's a 48 core, 256
Yeah.
gigs RAM on the processing side, 64 or 128 gigs, 24 core on the query side.
Yeah.
Yeah, we forgot to put the numbers in. Sorry.
Yeah, sorry, I forgot to update that.
So yeah, so just as I think we actually forgot to even put another slide in here, which was the context of, in fact, we replicate the data. So basically, there's a processing server that processes the data, and then there are multiple query servers. So that way, users can hit actually more than one query server at the same time. Because with something this large, it's not just the disk that's hit really hard, like where the 24, 26 terabytes of cube is. It's also the memory is being pushed through the roof. The CPU is being pushed through the roof to actually do all these calculations. So what you do is you actually have multiple query servers to address that stuff.
Yeah. And you would not want to be hitting the cube that's being built, trying to query it. It's a bad idea. Yes. I don't hear
I'm
very
sorry,
well.
can you say
Between
again?
what?
How do you sync up the data between query server and processing?
Okay, gotcha. How do you do the sync with the processing server and the query server? So the fast answer is that we're actually doing hardware REPL. Not hardware, REPL, sorry. Dear God, no. Hardware SAN snapshots. Okay, so in other words, basically, the query servers themselves are actually pointing to one cube, okay? And then we're processing another cube, okay? And then basically, when that's finished, then we just flip. We just swap the sands around, the LUNs for the disk around. And so then now the query servers are pointing to the new cube, and you can continue processing the old one.
So you have one processing server for one query server.
No,
No,
three
three
query
query
servers
servers.
to one processing server.
Yeah.
Yeah. So so actually, just as a quick call out, we actually have the SSAS operations guide and the SSAS performance guide. I forgot to put that in here too. So again, apologies. But actually, a lot of the lessons learned on exactly this, for example, and some of the other customers that we've worked with on doing SAN snapshots or replication. In fact, we've actually propped that that information inside there. So, but basically, that's the same idea. We have to. This is why you have to be buddies with your systems engineering folks, because you actually have to start taking into account of REPLs or SAN snapshots or things like that in order to be able to go ahead and get the latency down to a very minimal amount. Okay. So, all right. Last question, because yeah, we better. Otherwise,
Okay.
we're running out of time. Yes. I'm sorry. Do I use distributed? Oh, sorry. Yes. No, we're not using distributed servers. This is good old-fashioned, just single boxes. If it goes down, yippee-ki-yay, we have all the REPLs. So, yeah. Okay. All right.
Okay.
Yeah.
Let's keep going. So actually, this is a quick little snapshot of that web application. And inside of here, what we found is that initially when we built this thing out within Yahoo, by actually manually being able to optimize the data based on this, because they didn't have the ability to optimize at this level before, they were able to get double the eCPMs. That's effectively double the revenue on those campaigns that they were optimizing by having this data. And that was able to drive a lot more advertisers buying in, and it's been highly successful and very profitable for us. That's that. The other thing is, I mentioned that segment data earlier. Because it's such a challenge, because the data is roughly 10 times the size, other systems within Yahoo have never been able to report on it. So when we came in and we built the first cube based on this, it was the first time they were actually able to get those insights. And that also had a dramatic effect on how we've been optimizing those campaigns and making them more profitable. So future direction, again, those segment size or those segments, we're creating more and more segments. They're putting more and more targeting data inside of segments. So that number is just going to keep getting bigger and bigger and bigger. So that's a real challenge for us, especially in terms of that query performance. We've got to really work on our query performance, especially when they're using this segment data. We're also, okay, so we talked about the distinct counts. So we've been trying to build out frequency data, and we've been working on distinct counts, but ultimately we had a very, very important customer that needed it within 1 quarter. So what we did is we built a sampled data set, so we're doing a 1% sample on the data, and initially we built out these frequency counts because it means doing a distinct count of that user ID, that cookie ID, and all the data associated with it. So we built that out within Oracle until we got it working, and then we moved that up to the grid side. So right now, what we're loading in terms of being able to do frequency and uniques counts is that sampled data. And we load it into the same cube, but ultimately it has its own dimensions and its own fact data. So same cube, but really it could be separated out very easily. So that's how we solved it short term. We would like to have a better solution, but that's where it is right now. And it's working for people because they didn't even have that information before. So when they're trying to target their campaigns to say, how many times do we want to hit a user within a certain time frame, they didn't know where the profitability was. And if we have time for the demo, we'll see when you're doing the frequency reports, you can often see that there's a pretty dramatic drop-off in terms of how many times you hit a user. It might be just as profitable or even more profitable hitting them 3 times in a day or 4 times or 5 times, but eventually that profitability goes way down. So you need to have that frequency targeting on those campaigns, and the only way we can do it wisely is to actually have the data. And even that 1% sample does a reasonable job to allow them to not fly blind, to be able to set those controls appropriately. So again, Denny's going to talk a little more about going direct from Hadoop to the SAS cube and bypass Oracle altogether, and I'm a huge proponent of that. Let's see, the external access to cubes. So that's actually been something we've been working on a lot in the last couple of quarters. We have external customers that want to be able to get this very rich data and use it for themselves. So we have been building out a lot of security inside of the cube, taking advantage of the roles and everything to be able to secure down to the level that we need in order to go external. So it's been a big push.
And Diane would vouch for the fact that basically that the security context alone would be its own session. So just as a heads up, applying security on cubes can be tough.
It seems so easy. I'm like, this will take a week, no problem. And then it's just, things pop up every single direction and still are. So it's been a much bigger challenge than I thought. And then in terms of more disk, unfortunately this thing continues to grow. Shocking. We have more features and so we've got to come up with other solutions. And we are working on right now a solution to be able to expand it to beyond that 26 terabytes. But this one over here and others are pushing us really hard to come up with a multi-cube solution. Yeah. It's just hard because users literally want that everything by everything, and it's difficult to figure out how to divide it such that it still serves users.
Yeah, the funny story is that when the architect, Dave Mariani, who was on the stage 2 years ago at the PASS conference, and he was helping to do the keynote, and he was saying, and he didn't tell me that he was going to do this. He said, "Oh yeah, and our cube's going to go to 40 terabytes." And I'd already been screaming at them, like, "No, please shrink this thing." Because when I first talked to them, it was at 12 terabytes. We got, so we improved it, and I thought we're going to shrink it down, and instead it became 24. Then now it's 26. Well, at the rate they're going, Dave's right. It's going to be 40, and then I'll probably freak out on some of the floors.
Well, we also have a backlog of features, each of which add to the granularity and the size, but we're working on solving it first.
All right, saying this, we got 30 minutes left, so let's go to the big data analytics challenges, okay? So when you look at the basic concepts or the basic themes around this, okay, it's basically these 4 things, okay? I'm Microsoft-centric, so I'll probably have the analysis service as a cube and also talk about Excel, but the reality is it's something like this, okay, as a generic statement anyways, okay? You got Hadoop on the left side. It's the thing that's going to hold all this data, okay? Simple as that. In fact, that's actually even why we have HD Insight, right, over at Microsoft, because guess what? We're doing Hadoop, even though we had our own technology. We're also big proponents of Hadoop. We have a partnership with Hortonworks specifically because we know that Hadoop's what everybody's asking for. Okay? Then we build a warehouse of some type. That could be a Hive data warehouse. It could be an actual data warehouse. Doesn't matter. You have something that schematizes it at some point. Okay? So you can make it easier to understand. You can actually query. You have to have hierarchies of some type. Otherwise, the data doesn't make any sense. Right? You have a gender hierarchy or you have a geographic hierarchy. You have to have something that allows you to understand what the data is going through. Okay? Then you have a queue. Why? Because we want it fast. We want the queries to come back in seconds, not hours. Simple as that. So that's why we have a queue. There are initiatives that are out there to try to improve big data analytics performance. good luck. No, seriously, that's not sarcasm. I really mean good luck because it's a hard problem, plain and simple, okay? How some people have solved it is using this methodology that we have right now, but that's the basic idea, okay? And then you have some front end, because in the end, there is a front end that a user is going to use that makes it easier. Sometimes HTML5, sometimes it's a mobile BI device, sometimes it's Excel. I'm part of the team that actually was trying to kill Excel as the #1 most popular BI tool in the world. Guess what? I lost. So Excel it is, okay? So that's the basic idea. So we're just going to talk within the context of these 4 things here for the next 20 minutes. That way we have enough time for the demo. So I'm going to limit some questions so we can get through this, okay? Basically, we want to get the data out first. That's the first thing, right? You get the biggest problem when it comes to building these systems that you've put all this data in Hadoop and now you're going to move all this data somewhere else, okay? That's pretty painful. Okay, that's very burns the network, things like that. So how do you do it to make it a little bit easier? Okay, so from the context of how Yahoo has done it, and for that matter, many other customers have done it. First things first, you generate a bunch of files. Okay, that's what Hadoop does. It's a whole bunch of files, whether it's a Hive table or just good old-fashioned MapReduce that pumps it out, doesn't matter. You've got a bunch of files that actually is in the form of a table. Okay, column delimited, pipe delimited, whatever, it's in the form of a table that a warehouse, whether it be Hive or anything else, can understand. Okay? Now, if it's Hive, obviously you can usually keep it in the whatever format you want and just apply a bunch of Hive functions, but nevertheless, you generate a bunch of files. Now you're going to stage those files. You're going to transfer all those files, push them from your Hadoop infrastructure, and you got to push them all the way over to some staging folder so that you can put in a relational database. Now, a lot of people talk about Scoop. Okay? That is a good idea from the standpoint of making things a little bit easier in terms of having like an Uzi job just push the flow. Okay? Or you can use something like a Hive ODBC driver. In fact, actually, a couple slides from now, I'll talk a little bit about that. But the reality is when you talk about moving massive amounts of data, like Yahoo, good old-fashioned files. Okay? Literally drop the files, robocopy them over to the staging folder so they can be inserted into the database. Okay? So understand that there are tools out there that try to make it a little bit easier, but often for performance reasons, good old-fashioned dropping the files, bulk inserting them is actually the easiest way to do it. Okay? It really is. Okay? It's old school, it's dirty, it's ugly, and it's the fastest, most efficient way to do it. Okay? Then the Oracle and external tables option. What we did, quite simply, or what they did really, is they created a table, external table that pointed to those files that were dropped, and then now you can load the data directly into your Oracle database. Partition accordingly. And then from there, because we've got partitions in Oracle, we match the partitions with analysis services. So that way there's a one-to-one correlation between the partitions that occur in Oracle and the partitions occur in analysis services, so we can go ahead and run many processes in parallel. Because that's the other key thing we got to do, right? Later on, I want to, actually just the next time, I'm going to talk about how slow it actually is at times, all right? But the reality is you parallelize it to improve performance, okay? Let's see. Right, and then basically, yeah, processing is slow. So let's go to this. Now, why is this a problem for us? Why are we saying we would like to go ahead and see if we can skip the Oracle rack portion of this, okay? We want to skip it not just because of cost, not because I'm just for Microsoft, okay? We want to skip it because it's an extra step and it's an expensive one. That's what it is, okay? If you go from Oracle to analysis services directly, you're probably running about 10,000 rows per second. Okay? That's about the speed that you can get it at. In fact, if we go ahead and try to get the data from Oracle to SQL Server using the SSIS connector, on the low end we can get to 20,000 rows per second. And then from there, from SQL Server to analysis service, we can easily get 100,000 rows per second. Okay? So these, when you start talking huge amounts of data, 24 terabytes of cubes, these numbers really count. Okay? 10,000 rows per second faster really improves things. Now, how they can handle this because they parallelize it. So if it's one thread is doing 10,000 rows per second, if you've got 30 threads running 10,000 rows per second each, you're getting a much higher aggregate account. So that's actually how we've been solving up to this point. Just constantly knocking up the number of threads that we can handle. So as a general statement, the reason why the processing server is 256 gigs and 48 cores, literally at least one core is being used for one thread per one core. In other words, one partition is being processed for every core that they have in the system. Okay? So that's actually how you can improve speeds, because even though it's only 10,000 rows per second per thread, you got 48 of them. Okay, things are looking a little bit better now. Okay? So, but in reality, especially considering what Diane's talking about, they have more signals, more Cartesians out, more granularity. We're already hitting the end line in terms of our ability to go ahead and keep on doing this. So in other words, that 10,000 rows per second is really a barrier now, okay, for us to get more data into this queue. Okay, so that's why we're saying, okay, let's look at these options. So that's one option, by basically shoving to SQL Server, using SSIS to go from Oracle to SQL Server and just process through SQL Server. The biggest problem with that approach right now is data type conversion. We'd have to redesign the cube because the data types in Oracle and the data types in SQL Server don't match. Okay, so that's one of the reasons why there's a delay, because we're trying to figure out if there's an easier way that doesn't require us to actually go ahead and do that. Okay, which is the other one. Diane mentioned that there's this architect. Okay, well, that architect is Dave Mariani. Okay, he also was after leaving Yahoo, he became the VP of engineering over at Clout. Okay, so if some of you know me, then, well, you would have seen me and Dave on stage talking about this particular solution. In fact, what we did at Clout was it's a pretty cool thing. By the way, if you were here in the previous session, there was Kai Onkroth standing on stage. Kai Onkroth is the guy who created this cool looking diagram. He makes me look a lot smarter than I actually am, okay? So what he did was the call out is basically this. We have the data warehouse SQL server, okay? We have the SQL server, the Hive on the left side, in yellow, okay? We have a SQL server in the middle that's green, and we have analysis services blue on the right. But what we did was we created a Hive ODBC driver connection from SQL server. The SQL server is sitting on the same server as analysis services, okay? So on the same server, okay? We take the Hive ODBC driver and connect it directly to Hive in Hadoop, okay? And so what ends up happening is that from analysis services perspective, it's just a SQL Server view that I'm connecting to. Because what we did was create a SQL Server view that used the Hive ODBC connection to talk to Hive. Okay? So that was a cheat. Okay? It's a hack. And for anybody that's IT-centric, everything I just said, link server connections, views, things like that, should not work. Okay? I want to call that out very clearly. This should not work. Even when I was helping Dave do this, I was going, yeah, right, this is never going to work. In fact, it worked so well, we didn't just publish a paper on it, we went into production within a month of starting this test, okay? Because even though it was slower than we would have liked, okay, the fact is it was actually surprisingly stable, number one. Number two, it was easy to restart. Either the transaction made it or didn't. So if it didn't make it, just restart it. That's all you had to do, okay? Yes, the data was slow, but the things that we could run, same idea, we can run 48, 49, 50 threads all at once. We didn't have to stage the data. That was the key thing. So remember what I just said in the previous slide, right? First thing I have to do is move it from Hive to Oracle. And then Oracle, I have to do processing to it to create the partitions, and then I can shove it to the cube. Or with this option, I Hive or Hadoop into Oracle, connector to SSIS to SQL, and then do it, right? So in other words, a whole bunch of steps in between. In this particular design, there are no steps. It's Hadoop Hive directly to the cube using SQL Server basically as the bridge. That's literally what we did, okay? So there were less steps. So even though the steps might have failed more often in comparison, it was actually okay because it was easy to catch because it either worked or didn't. Okay. Once it didn't work, we just simply restarted that. Okay. We just built a little quick engine that basically, ran 48 threads. If a thread died, it's in a transaction, kill it, restart it. That's all you got to do. Okay. And so because of that, so even though the processing was slow, we're talking like somewhere like 5,000 to 8,000 rows per second. Okay. Not even 10,000. But because we didn't have to do all these extra steps, it was faster. Okay? So in fact, that's one of the things we're also looking at right now to figure out if we did it at Clout, which was a 2 to 3 terabyte cube, okay, and we did it very comfortably. So on paper, surprisingly enough, it should work for Yahoo. We're still experimenting though, because immediately enough, it is a 26 terabyte cube that might bring a whole new ballgame that we haven't taken account of. Okay? Yes.
Quick question: who's the ODBC driver for Hive did you use?
Oh, we used the Hive ODBC driver we used ours, okay, the Microsoft one. So in fact, just to be very clear, the Cloud system is a Cloudera system, okay? So what we did is we actually, Cloudera CDH3, not CDH4, so CDH3 is running on Hive ODBC 0.7 right now. So we actually used one of the older Hive ODBC drivers that allows us to do that connection, okay? All right, cool. So, seeing that, let's see, we got 42 minutes, all right, 10 minutes left. All right, partitioning, partitioning, partitioning. I'm actually going to skip through most of these slides because I want to try to get to some other concepts. But the key call out, okay, is that, actually I'll just go to this slide. There we go. Basically, the call out that we're trying to show here is that we did a 1-to-1 ratio from Oracle to analysis services, okay? So that way we could actually, as soon as a partition was created in Oracle, we could create the partition in AES. There'd be a 1-to-1 matching so we could run the threads in parallel. All of them could run in parallel without interfering with each other. Now, sometimes we might have to merge the partitions on AES together because we actually would create like tens or hundreds of partitions on the AES side, so we would merge them after the fact. But the reality is that that was still faster because we could go ahead and run the stuff in parallel because Oracle to SQL Server was too slow. Okay, so whether if we decide to do the Hive ODBC option or the SQL Server option, we'd stick with the same thing. Okay? None of that changes. Partitioning is excessively important because in the end, it doesn't matter how good the transport is, it's still a lot of data that has to move across the wire. Ultimately, that's what it comes down to. So if it's a lot of data that moves across the wire, partitioning allows you to parallelize it, so hence partitioning, 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 because we really want to read that point across. Okay? All right, let's see. Okay, so now I'm going to go a little geeky on you. So it's called It Is the Order of Things. Okay, so the reason I'm saying geeky is because the next reference is to Deep Space Nine. So the reason I say that is because actually, how many of you watch Deep Space Nine? Just curious. Okay, so not that many. Okay, forget it. So anyways, for any of you that you do watch it, basically it's a reference to Jem'Hadar. That's one of the aliens, and basically he kept on a reference called It's the Order of Things, because the context was very simple. You do it no matter what. Your life depends on you following not just doing it, but doing in the correct order. Okay, that was the context within that particular episode. Okay. For any of you Battlestar Galactica fans, it was also written by Roland Moore. So, but anyways. Okay. But why is that important? It's really important. Okay. Now, maybe not life-threatening in the way Jem'Hadar and Deep Space Nine is, but very important from a Q perspective. And the reason why is because, okay, this is a lot of data inside here. So let me give you the theme first, and then I'll go into the data part. The theme was this: we put the data out of order by accident. Okay, as we're processing from the facts. And within 2 weeks of that actually happening, Diane calls me up, says, our cube just went from 24 terabytes to whatever.
Yeah, it's about 50% larger than it had been before.
50% larger. Now, on a 24 terabyte cube, 50% larger is pretty important, okay? We're running out of disk space. We're running out of memory. We're running out of everything. Oh crap, what do we do? And we're going, wait a minute, we didn't add more data yet. All we did was do a switch. We switched from one system to another system. The source system, that was, okay? So the Oracle rack system that was connecting to Hive, Hadoop was slightly different, so that's what we did. But we didn't actually add more data. We just switched systems. So what the heck happened? All right, here we go. Now for a little bit of the teaching of the internals of analysis services. Okay, so the way it works, analysis services works, okay, here's on the left portion of this, okay, is that when it takes data, okay, processes data, it organizes it and tries into what they call segments. This is different segments from the web analytics segments that Diane's been talking about, okay? We internally call segments, okay? And so we try to arrange data that's basically non-unique and try to put them together so that way we can represent that data in a different way. Okay, so in other words, if you got 1, 2, 3, 4, 5, and it's a row that has 1, 2, 3, 4, 5, and it's repeated the same like 5 times, instead of writing 1, 2, 3, 4, 5 times, you just write 1, 2, 3, 4, 5 once and call out the fact that it's done 5 times. Okay, that's an oversimplification, but that you have 1 row instead of 5. Okay, that's the basic idea of the segment concept. All right, the data became out of order. When we switched from one system to the other system, source system, the data was no longer in the order analysis services was expecting it in. So what happened was that now the segments, if you were to say that these segments were like the blue, the whites, the reds, the yellows, these are all rows that are actually similar to each other, okay? We're all out of whack, okay? Since they're out of whack, we couldn't compress them very well, okay? Because there was a whole bunch of non-unique data sitting next to each other. If they're all sitting next to each other, we can't compress that stuff very well, okay? All we did is we went back, rejiggered the source system, both Oracle and AS, told it to do the distinct and ordermize. That's all we did. So then what happened is...
Actually, initially it was just in the database.
Oh, that's true. Initially
Yeah.
it was just in the database too. That's fair enough. the bottom part then basically allowed us the non-unique data to be sitting next to each other. So all the blues are next to each other, all the whites are next to each other, all the reds are next to each other, the L's are next to each other. So we can compress them better. So ultimately what ends up happening is under the sorted section, we can compress the data better, so now it's a heck of a lot smaller. Okay? So basically, because the data was not sorted correctly, we literally had a 50% increase in the cube size in 2 weeks. All right, so let me stress that. 2 weeks, we got a 50% increase in cube size. That's pretty massive. So you do the sort ordering right, all of a sudden that cube becomes a heck of a lot smaller because we can take the non-unique data, put them next to each other because you sort them correctly, all right? We can compress it down. All right, and that's actually how you can keep the cube sizes smaller. Just to finish my last point, then yes, question. On the left, if you look at this file, don't worry, I'm going to give out the slides, so don't worry, okay? But basically, if you look at the numbers here, you have the sorted versus non-sorted. The fact.data file, okay, that's the top one there, okay? It's 195 bytes, or kilobytes, okay? Sorted, but 344 kilobytes not sorted. Okay, so we're talking a pretty huge difference. Okay, so sorting, getting the order right is really, really, really important because you can save a lot of space this way. Okay, all right, one question, then we got to go on.
Well, I was just going to add, and later we went back and we tried ordering in the partition queries, and we also got a pretty dramatic size reduction there as well. So it needs to be ordered in the upstream database, but then ordering it again, once it's already ordered there, it's pretty quick. It didn't actually affect our processing time by much at all, but it did affect the size again, because I guess it's the size of data that's coming in is still pretty small when it's coming from Oracle in, and so that surprised us. We didn't expect it to have any impact, but it really did.
Yes. No.
Yeah, how do you decide the sort order?
Oh, okay. So how you decide the sort order is
Granularity.
unfortunately is very simple, but unfortunately very tedious. Okay. So basically, what it comes down to is that it's based on the granularity. You look at the data to figure out what is repeated versus what's not repeated. So in other words, like if you've got like a web page hierarchy, that's typically not very unique. Very unique. So that's the last thing you're going to sort on. Versus time and date. That's very common. That's usually repeated. So you would sort on date and the time first. That's an example. Okay. But in reality, you sort it that way by analyzing the data and then you try. That's really what it comes down to.
Yeah,
It's
I ran
really-
a billion tests on this, and ultimately, we didn't end up having to order every single dimension, every single key. It was kind of hitting about a third of them had 90-something% of the impact.
Sort of like when you,
But it was a little bit trial and error to figure out which ones those were.
so, sort of like when you create indexes on tables, with the SQL Oracle, same idea. You sort of have to. You have a rough idea, but you're gonna have to try it a bunch of times anyways. So, okay, last question. Sorry.
Are you making a trade-off in performance by ordering?
No, in fact, actually, quite the opposite. Good question, though. Are we making a trade-off in performance? No, in fact, actually, we are definitely improving query performance because now that since the data is more compressed and smaller, AS is actually able to use a lot less CPU power to actually get through all the data. Because the way AS works, it is. Oh, sorry.
Upstream, you do have to do it, though.
Oh, yes.
Yeah, so you are taking somewhat of a hit
Oh
up
yeah,
there.
sorry, yes.
For us, our upstream process isn't as much of an issue. Our queue building is our bottleneck, so that wasn't an issue for us. But it could be for someone else.
Is it both performance of building the cube and querying the cube?
Yes. Yeah. In this particular standpoint, it's actually completely both. The performance of both building and querying the cube. All right. Final little geeky prospect. If you guys can get the association that I'm about to ask you guys, then you get a free copy of Professional SQL Server Analysis Services 2012. Okay. That's one of the books that I wrote. I apologize in advance. And if you can figure out the reference, then you can. So what's the reference here? It's actually for two pretty cool things that I wanted to call out. Oops, sorry, I actually gave you the hint. How do you associate dimensions with Star Trek Into the Darkness? Star Trek's coming out. It's very cool. Sorry? Parallel universe, almost. Yeah, but that's right. Anybody can guess? I actually sort of give you a hint when you say across the 8th dimension. It's an old one. Huh? Right. Exactly. Buckaroo Banzai across the 8th dimension and Star Trek Into the Darkness. They both involve Peter Weller. So just as a quick. So you hit me with your email address. I'll give you the book. All right. Now back to the real stuff. Okay. Why am I doing this dimension thing? Because you know what? Processing dimensions is a serious pain in the butt. Okay. I'm going to finish this in a minute, so that way Diane has enough time to do the demo. Okay.
Sure.
All right, but here's what it boils down to, the two key themes. When you have big dimensions, processing update is a serious pain in the butt. Don't do it. Simple as that. Just plainly outright don't do it. Make everything a type 2 dimension so you can do process add, okay? If you have to do a process update, wait till the end of the week, end of the month, end of the quarter. Do it then, because when you do a process update, by definition, you're reprocessing the entire cube, okay? That's really painful, especially when it's a 26 terabyte cube, okay? So admittedly enough, it's only processing the indexes and facts, but that's a lot of aggregations, and in fact, the aggregations is a pain in the butt for her.
So this was actually a very early version of the spreadsheet that I use when I'm designing all the aggregations. For us, the actual size of the cube is crucial. Every decision we make is right now bound by the size of that stupid cube. So with the aggregations, we rely completely on the aggregations. We don't want users ever hitting partitions, but they have to be as small as humanly possible. And so literally, I hand build these every quarter. I now analyze all of the query logs, everything else, and figure out exactly what needs to be in there. And it's obviously not perfect, but we kind of get the best balance we can. But it's tedious and ugly, and no one else in the world understands my stupid spreadsheets with all their colors and things. There's got to be a better way to this. I want to pass it off to someone else, but then, I don't know, no one really wants it. I can't imagine why they don't want that job.
So as a quick hint, one of the things that we're also experimenting on is that as of SQL Server 2008 R2, this usage-based optimization, you can turn that on, try to use that as a way to build aggregations better. But just like typically anything with aggregations, you don't build it for everything. Okay, you're very specific on building for the slow running queries, and then you optimize for just those, which is exactly what Diane does in order to optimize such a massively large cube. Okay, all right, so let's switch to demo mode because that's what this is.
Okay, cool. All right, we'll do a really quick and dirty demo over here, hopefully.
So as she's doing it, I do want to call out that she is doing it on Tableau. Yes, it is a competing product. They are looking at Power View right now. That's real. That doesn't mean making it up because I'm a Microsoft guy. So we are looking at that, but by the same token, in order for them to do ad hoc querying, they're right now using Tableau to actually look at data. So just a quick call on it.
So right now, in here, what you'll see is a bunch of dimensions over here to the left, a bunch of measures grouped up into folders. I'm sure you guys are familiar with all of that. And I'm just going to look at a few measures in here. So we have impressions. This is just for one insertion order, by the way, so kind of one campaign for one day. That's the data set that I'm looking at the moment. So it's less than 2 million impressions. Our revenue eCPM, that's an effective measure of the revenue that's being generated by this campaign. And eCPA is the effective cost per acquisition. So in this case, there's a pixel tracking every conversion that a user makes, and we can bring that back down to what the effective cost of acquiring a new customer, say, is. So I have these different measures. I'll look at them by age first off. Just drag in age, and we'll take a look at that. So in this case, we have some data that's unclassified, and that's simply because we don't have age data for everybody. So where we get it, we have it in here. And this allows us to easily see what age groups. You can see at the bottom what age groups are getting hit. The number of impressions, that's how many ads were served to these people by age group. And then in terms of the revenue, we can see these lower age groups are actually generating a lot more revenue, even though we have a lot fewer impressions being served to them. And in terms of the cost per acquisition, that cost per acquisition is quite low for those folks. It's actually really high when you get to the 65 plus age. So if I were looking at this data, I'd be saying, oh dear, we need to be targeting some of these lower age groups, maybe 18 to 34. We want to bump up and start serving a lot more ads to those people and a lot less to our seniors and folks that are older. So that's the kind of insights you get. I'll move to, let's see, region. I pre-populated a tiny bit of data just to make it a little bit faster in here. So I have a full day of data in this cube, but I had to scramble all of it so you guys couldn't see what it was, except for a few specific things. And I did grab data from, it's a specific campaign in Europe. So what you'll see in here is our top regions hit are all in the London area. So I'm going to keep only on those guys. And again, we'll just check out what the performance looks like on them. I like looking at graphs because it's just easier to see. So here I can see in Greater London, if I look at that, again, that revenue performance, we're serving most of our impressions to Greater London, but the revenue is decent, but it's not as high as some of these others. So I might want to go off and target Greater Manchester or East Sussex. And it's kind of bogus, but And then in terms of gender, I can add gender and a color, and then just see how it breaks down by gender. And again, I'm going to remove this unclassified data. And now I can see that, okay, so we're serving, blue is males, so we're actually serving more data to males, but it looks like we're generating more revenue from females. So again, we might want to start bumping our targeting a little bit to get that, to hit those people that are more profitable for us. On the segment side of things, I pre-populated some filters here, but just quickly, we can look at segments. Here's our segment data.
So as she's doing this, basically the call out, as you can tell, this is how fast she's actually going through all this data, right? And that's more or less the call out, right? If you want to go through all this data in Hadoop, good luck, right? I mean, it's a great, don't get me wrong, it's not a knock to Hadoop, it's a great system. It's just that you can't ad hoc query this stuff. And this is, in fact, exactly what Diane, folks at Yahoo, and her customers actually have to do, right? They have to be able to look at all this data extremely quickly, extremely fast to make decisions right there. Just like she noted, it's a 2-week campaign. So seconds count, right? They have a 2-week advertising campaign. They got to get as much information as they possibly can in a short amount of time so they can act on it and say, oh, okay, you know what? East Sussex females buy more stuff. We know this is fake, but East Sussex, okay, so target East Sussex females, right? That's the idea, that they can do things like that on the fly. So that's why they're generating more revenue. That's why they're generating more profit for both the customer and also for Yahoo. And sorry, go ahead.
Oh, no problem. So this is a list of some of the top segments, and again, this is number of impressions being served. The colors are actually associated with these different sizes. So that's the size of the physical banner. And over here, we have that cost per acquisition. So if I look at these purple ones, this particular size here, this 160 by 600, the cost per acquisition is actually pretty small, and we're serving lots of impressions. So we're probably making the right decisions by serving a lot to that group right there. The cost per acquisition is also pretty small for these brown guys, these 425 by 600. So in that case, I might want to bump up how much I'm serving to them. But that's specifically for certain segments. So you can look for outliers within these segments to see, like in this case right here, this cost per acquisition is pretty huge for this size. So for this particular segment, I might want to reduce that targeting. So again, they can get to a pretty finite level of targeting via this. And let's see, one more thing. What's that?
Oh, no, we're good. Oh, I'm just saying we're at 12:15.
5 minutes, okay.
Okay. Yep.
Really quick, okay.
No,
So we'll look at segments here. Let me look at one other type of view.
Oh, yeah.
And this is segments across everything. I'm gonna drag impressions into this size. Whoops. Actually, hold on. Okay, this got
We
all
like
messed
bubble
up.
charts. Sorry.
ECPA up here, impressions down to here. And we'll bump up the size of those a little bit. Okay, and then I'm actually going to look at screen type, and I'll explain this in a second here. So screen type is just, are we serving it to mobile devices, mobile smartphones, feature phones, or PCs? So we're starting to look at that a whole lot more within Yahoo now. And again, this is a look at kind of top segments across the network for a specific market, so that's a regional area. And I'm comparing the click rates over here, so that's one measure of performance, versus that cost per acquisition. So it gives you just a high-level visual to see, oh my goodness, look at all these based on the PC. So regular banner ads are getting much higher performance, and all of their cost per acquisition are significantly smaller than these ads that are being served on mobile smartphones and mobile feature phones. And other is just within that same, it's another screen type that hasn't made it into our system yet, I believe. But you can just kind of get a snapshot of how at large these different screen types are performing across the network. And then the last thing I'll show you is just with frequency. This is where we created a new measure group and new dimension based on the sampled data. And so you can see the measures down there. And we have this one up here. I'm going to look for a certain insertion order. So I created a kind of ridiculous advertiser in here, toss a coin marketing, woohoo. And for frequency, we can look at frequency buckets. So what this is going to show us is for the number of times that a user saw an ad, what was the performance. So I'll look at it this way. Promise we'll be done really quick. Okay, so what we can see here is this is the number of impressions that were served to people. The first bucket right here is the first time an ad was shown to a person. This one is the second time an ad was shown to a person. third, fourth, and so on. So you can see how the performance actually works for those people. So in this case, we can see the performance actually peaks out at the third time someone saw that ad. The fourth time, it's still pretty high, but then by about the fifth time, it drops off. So most likely, if I were optimizing this campaign, I would stick a frequency cap of 4 on this campaign, and then I'm probably gonna, if these numbers are right, I'm probably gonna increase my performance, and I'm not gonna be buying a whole lot of ads that are just not performing well for me. So again, we didn't have that information before, so while the users were setting frequency caps across all their campaigns, they were doing it blindly and kind of guessing at what it was. So now we can actually see that data. Even though it's based on a sample, it's still very powerful.
Okay.
That's it.
Perfect, thanks. All right, so no, actually, we're gonna just close up because we're already right, but then we can ask questions afterwards, of course. So we just want to call out that, where's the, sorry. Oh, right, there we go, thank you. And so we just wanted to call out, I think that's it for our session. We ran about 5 minutes late, so we apologize for that. But then if you have any questions, we'll be all here off to the side. Please do submit your forms. Tell us what we did right, what did we do wrong, and thank you very much.